All right, sixth graders, we are starting a new chapter, chapter 9, which covers surface area and volume. Now, you've touched on this in the past. However, we're going to go into much more detail and applications with this work. First off, let's review, or not review, this might be new to you, what a polyhedron is. Make sure you are writing these in your notes. A polyhedron. Now, poly is actually a Greek word that means many. Hedron means face. So a polyhedron is a solid with flat faces. Basically, you can't have curves. So a cylinder is not a polyhedron. A polyhedron is just a solid with flat faces. The next thing we're going to talk about is this. Obviously, this is a Kleenex box. This right here, pretend this is flat on the top, this right here is a prism. However, this candle, it's a cylinder, but this is not a prism. Why do you think this is a prism and this is not? Here's why. A prism is a solid figure, which is called a polyhedron, whose two ends are called bases. Now, two end faces are called bases. Now, those bases, those end faces, must be congruent and parallel, and whose sides are parallelogram, and that's why a cylinder does not work. A cylinder is curved, therefore, the side of a cylinder is not a parallelogram. Even if you unfold it, it becomes a parallelogram, but it's curved, therefore, that's why it's not a prism. And lastly, a lateral face. A lateral face are the faces of the sides of a solid that are not the base. So they cannot be the base. So we're going to start with the rectangular prism like the Kleenex box that I showed you. Now a rectangular prism, now make note of this. A prism is named based on their bases. So a rectangular prism would have bases that are rectangular. For example, a square prism would have squares as their bases. A triangular prism would have triangles as their bases. A trapezoidal prism, trapezoids as their bases. An octagonal prism, and etc. So, here we go. The surface area of a rectangular prism is the sum of the areas of all the bases, these two bases, and the lateral faces. Now, there is a specific formula, if you want to use it, there is a specific formula for the area of a parallelogram. Now, before we look at the formula, let's look at our rectangular prism here. You will see that the two bases must be parallel, and in this case it's the top and bottom. They are parallel and they are congruent. Now someone's going to say, well, Mr. Humphreys, why can't I take this and turn it? And now I can make this side and this side the base. You absolutely could. That will work. A rectangular prism, you can make any opposite sides as long as they're congruent and parallel, you can make them the base. So, lateral faces are here in the blue. The base is here. Now, the lateral face makes one big rectangle. We would actually find the area of each side. So you can find the area of the top, the bottom, the left, the right, the front, the back. That's why you have two of each of them. For example, if you look at the picture, the bottom, length times width. Length times width. Well, the top is the same. That's why we multiply it by 2. That's the area of the bases, length times width. Now, the left and right sides, h and w, width times height. Well, the right and the left, they're the same, so that's why we multiply it by 2, 2wh. And the front and back are represented by 2lh. You basically multiply each thing by itself and times it by 2. So the area of the bases plus the area of the lateral faces. Make note of this. the area of the bases plus the area of the lateral faces. All right, so example 1, let's find the surface area. Now the surface area, I always suggest, and I know as 6th graders it's very easy to skip steps. Please get used to writing the formula down. Surface area equals 2LW plus 2LH plus 2WH. Now I'm going to let this be the length, width, and height. So now I just plug everything in. Twice the length multiplied by the width plus twice the length multiplied by the height plus twice the width multiplied by the height. So I just simplify this. 2 times 3 is 6. 6 times 5 is 30. Plus 2 times 3 is 6. Times 6 is 36. 2 times 5 is 10. Times 6 is 60. I add them up. 30 plus 36, 66, plus 60 would be 126. Since it's area, it's going to be squared inches. So the surface area of this prism is 126 squared inches. Now you could have drawn the net, like you could have drawn this out as a net. And by a net, I mean something that looks like this, and it's going to pop up here. But you could have drawn it out and find the area of each piece and then add them up. But using the formula is much easier. So these are 2 extra examples. If you want to do them, you can. Otherwise, try one of them, try both, or you don't have to try any if you understand it. But number 1 would give you 52 squared feet if you did it correctly. And number 2 would give you 288 squared meters. There's extra examples to study from if you need it. Now you're probably going to ask me at some point, well, Mr. Humphreys, not everything is a rectangular prism. So I can't use that formula. And you're going to be absolutely right. Here is what you need to know. Now, it's completely up to you what you want to do. For example, here, what kind of prism is this? Find the 2 bases, which are parallel and congruent, which they're represented in red. They're triangles, so this would be a triangular prism. Now, I've unfolded it for you, but here is the key. If you really wanted to, and you wanted to find the area of the green rectangle, the purple rectangle, the blue rectangle, the red triangle, and you wanted to add them all up to get the total surface area, you are more than welcome. But we can write a formula, and here's how you do it. A prism has how many bases? How many prisms, or how many bases does a prism have? What we can do, go Cubs, what we can do is write a formula. And we know that we have 2 bases right here. There are 2 bases. In red, there are 2 bases. So I'm going to write this down. We know the surface area can be 2 capital B. Now capital B stands for the area of the bases. And then we could add what? What do we call this? We call that the lateral area. So the lateral area, let me erase this here. So the lateral area is going to be each of these, but we can go one step further, and this is what I love. Absolutely love this. So let's write this. Let's write lateral area. I'm going to put LA for lateral area. But let's think about how you would find the lateral area. I could find the area of each individual rectangle, but I can make this one big rectangle and just do base times height. But the height, they'll always give you. But the base, they won't, so you have to find it. How can I find this base? So what could you do? If I wrap this base up, it's going to wrap around the base triangle. So what is that? That's the perimeter of the base. So to find the lateral area, this is key, absolutely key. take the perimeter, the perimeter of the base multiplied by the height of the prism. I wonder if I can draw myself. Oh, I can. Interesting. All right, so area of the bases added to lateral area. And there's our formula. So the formula, area of the bases added to the area of the lateral faces. But make note, how do I find the area of the lateral faces? Perimeter of the base times height of the prism. Say it again. The perimeter of the base multiplied by the height of the prism. Don't forget that. So here we go. Let's find the surface area of the prism. And ignore this part where it says draw a net. That's extra work. We don't want to do that. So what do we need? Surface area. We need the area of the bases. Now that's why it's big B. Big B stands for area of the bases. So area of the bases, let's look. We have a triangle. That's obviously it's a right angle. So base and height are 3. So the area of the bases. Now how many bases do I have? So we're going to do this. 2b plus lateral area. So 2b, or not 2b, just kidding. So 2 bases. Each base is a triangle, 1/2 base times height. The lateral area is the perimeter multiplied by the height of the prism. So what's the perimeter of the base? Perimeter of the base, 3, 4, 5. 3, 4, 5. What is it? 3, 4, 5. 3 plus 4 is 7. Plus 5 is 12. So the perimeter of the base is 12. Multiplied by the height of the prism. The height of the prism is this piece right here. What connects the 2 bases? So it's 12 times 6. So equals 2 times 1/2 of 3 times 4, because that's the area of the base, plus that would be 72. Now we just simplify. 1/2 of 12 is 6. 2 times 6 plus 72. The surface area is 12 plus 72, which would give us 84 squared meters. So 84 square meters would be the surface area of this triangular prism. Here are 2 extra examples that if you want to do them, you can. 2 extra examples. If you did them, number 3 would give you 150 square meters, and number 4 would give you 60 square centimeters. Now, when you get to a cube, all sides are equal. So if all areas are equal, I just find the area of one side, and I multiply by 6. And that is the formula for surface area of a cube. When all edges of a rectangular prism have the same length, S, the rectangular prism is a cube. The formula for the surface area would be S equals 6S squared. So if we would find the surface area of this cube, we'd plug it in. S equals 6S squared. We find the area of one side, which is just 12 squared, 12 times 12, and we multiply by 6. That would give me 864 squared meters. All right, that wonderful thing is an emerald ash borer. Now, why is that important? Because it kills trees. So we're going to do a problem in which we're going to talk about the trap that is made to catch these bugs. So the outside of purple traps, here's our purple trap, is coated with glue to catch emerald ash borers. You make your own trap in the shape of a rectangular prism with an opening at the top and bottom. What is the surface area that you need to coat with the glue? Well, wait a minute. If you think about it, we don't have either one of our bases. So all we want to use is the lateral area. So we have two options. You can either go back to your formula and take the lateral area and do this, or this is what I would do. Remember how you find your lateral area? You take the perimeter of the base and you multiply it by the height of the prism. So let's think about it. Perimeter of the base. Our bases are that. So if I find the perimeter of the base, that's 10 plus 10 is 20, plus 24 is 44, times the height of the prism, which is 20. So the lateral area would be 44 times 20, which is 880 square inches. Now you could have plugged all of these in for the length, width, and height. But you could have also just found the area of the base, the perimeter of the base, and multiplied it by the height of the prism. And here are the 4 vocab words that you should know from this section. And actually, we're going to add one more. The last one we're going to add lateral surface area, which is the sum of the area of the lateral faces.